Okay, I'm going to do two problems today for you. Here's the first problem. It's going to be dealing with water, and we're going to have it's water vapor basically here. So what we're going to have is we're going to have a compressor. Okay, state 1 coming into the compressor, state 2 coming out of the compressor, and we are having to put some work W dot into that compressor to make it run. And we're dealing with this, we want to find out what is the isentropic efficiency of this compressor. That's what we're going to try to figure out here. That's what we want to figure out. When we do problems like this, what I like to do is set up, and I like to say state 1, state 2s, and state 2. And I like to draw this on a TS diagram as well, TS. And we're dealing with water vapor, so we're going to have a vapor dome. And we're going to have our pressures like this, and I'm going to say this is going to be my state 1. This is going to be my state 2s. This is going to be my state 2. It's important to me that you're able to draw these. It looks like 2s is about straight up from state 1. 2 has to be to the right. If you don't draw that, that'll be points off on the exam. I need you to understand how this works. Okay. The problem statement told me that state 1 was a saturated vapor at a temperature 1 of 300 degrees Fahrenheit. Okay. And it told me that the pressure at state 2 is equal to 800 psi. Okay. And that's what it told me. It also still told me that the mass flow rate is equal to 5 pounds per second, and the power that this is required is 2,150 horsepower, which we know that is coming into our system. And they wanted me to. Now, in my state 2s, I know a couple things. My state 2s can be helped define by my state 2 and my state 1. So the first thing I know is state 2s has the same pressure as state 2. Look at it, it's on the same line there in the diagram. So if I look there, I say that P2s is equal to 800 psi. So I know I'm getting that value from state 2. Always will, in every case. Okay. Now, for things that have vapor domes, I can also say that S2S is going to be the same as S1. Okay, S1 and S2 are the same, remember? Look at this, S1 and S2 are the same. So here we go. Let's look here, and if I look these values up, saturated vapor temperature 1 is 300 Fahrenheit. Again, I think that's a pretty easy table lookup. I can find the enthalpy of 1 is equal to 1,180.2 BTU per pound. And S1 is equal to 1.6356 BTU per pound per degree Rankine, and then I write that right over here as S2S is equal to 1.6356 BTU per pound per degree Rankine. And that is easy and simple, and we know that's always the case for things with vapor domes that are not ideal gases. This is what happens. Okay? Now, we can use this information to help us find, now that we have 800 psi and 0.16356, we can now find what state 2 is. And so 2s is. So let's look at what state 2s is. Okay. I'm going to open up my tables, and I'm going to go look here. Let's put on the document camera. We're going to go look at 800 psi. 800 psi, which you can't see here, 800 psi. 800 psi, we're going to have saturated vapor is at 1.4160. We're at 1.6356, so we're well above that. We're going to be a superheated vapor. So let's go to our 800 psi superheated vapor. It's down here, 800 psi. Superheated vapor, and we're going to look, where does 1.6356 go? 1.6356
Oh, it's between two numbers. It's going to be between 800 and 900. And so I'm going to have to interpolate between these two values and these two values of enthalpy to find out what my value for H2S is. Now I could find out what my T2S is and then use that to find H2S, but that's an extra step I don't need. Interpolate between these two numbers and these two numbers. And so I'm not going to do that here. I'm going to just give you the value that H2S, when you find that, and maybe it's good practice, would be 1448.8 BTU per pound. Okay. Now, if I look at that and I say, all right, here is, let's find the isentropic efficiency. I know that's equal to H2S minus H1 all over H2 minus H1. And you're saying, Dr. Winklin, I don't know what H2 is. Okay, so we could find out what H2 is because we know that W dot of the compressor is equal to M dot times H2 minus H1. Okay, and they know that that's 2150 horsepower. And since we know H1 and we know M dot, we can find H2. That is a completely acceptable way to do that. Okay? It's a completely acceptable way to do that. I would encourage you right now to do that. Okay, and I'm going to give you that value. Okay, if you're done pausing, I'll tell you what H2 is. So H2, there's going to be some conversions here. H2 is going to be equal to 1484.2 BTU per pound. And that will give me also that S2, when I look up at 800 PSI and 1484.2, that gives me S2 is equal to 1.6611 BTU per pound per degree Rankine. And this one here, I'm going to have to interpolate S2 as well. Okay, I talked to you through this. If you don't know where H2 or S2 comes from, I need you right now to pause. I need you to write me an email and say, Dr. Winklin, I can't figure it out. Let's Zoom. Let's figure this out. Let's talk about it because I want you to understand this. This is something you should know for the third exam. Okay, how I found those numbers. Isentropic efficiencies is on the final exam. This thought process of where the states all lie, pretty good understanding of. Okay. So in this problem now, I have set my state H1, S1, H2S, S2S, H2 and S2 with the information that I've been provided. I had to use my secret coder ring to understand what they were telling me, how they were telling me it, so I could figure out it wasn't directly given to me. That is where I really want you to work with. If you have been looking at other sources to help you solve your homework, you're missing this very important step. How do we choose the path that we're going on? That's the entire focus of thermo. The entire focus of thermo to do that. Okay? So, if you got this here, if you're okay with this here, then I want you to calculate what the isentropic efficiency of the compressor is, and that is going to be, well, I'm not going to tell you. That's going to be your quiz question for this problem. Now, the other thing I could ask you on this question is, what is the entropy produced for this compressor when it is in a real situation? What's the entropy produced? And you have enough information to find out what the entropy is produced here as well, using the second law. So I only want you to figure out this number. Okay, that's what you're going to do for your quiz question. I'm going to tell you the answer to sigma dot is 0.1804 horsepower per degree Rankine. And I would encourage you to continue this problem and find out what sigma dot is for this compressor the actual compressor. Okay? All right, we'll end this here, and I'll now do a problem that deals with ideal gases.